Hello my friends and welcome back to the Today Machine channel. At the Nexans plant in Lens, France, copper cable production begins with the foundry's 24/7 operation, which processes 170,000 tons of copper annually. The process starts with copper cathodes, large copper plates, melted in a furnace at a temperature of 1250 degrees Celsius. Once fused, the copper is hot rolled into rods. These rods are then drawn into fine wire, down to 0.8 millimeters in diameter. In Autun, the production process continues with insulation. Raw materials, primarily plastics, are stored in silos, with 40,000 tons processed annually. These materials are mixed and granulated, followed by rigorous quality control. The copper wires are insulated using specialized sheathing techniques, and color marking, using the distingo process, is applied to distinguish different sections. The cables are then cooled, measured with laser counters for length accuracy, and marked with the metrium system, which indicates the number of meters left on the coil or drum. The final products, such as U1000 R2V distingo coils or drums, are packed for distribution, including in the Mobiway system for easy transportation. The bunching process involves taking fine copper or aluminum wires and twisting them into bundles. The fine wires are drawn from larger wire spools through bunching machines, which bring together multiple strands in a helical arrangement. Stranding involves twisting smaller subunits of wire to construct larger conductors. In some cases, cables can be manufactured up to 630 square millimeters in cross-sectional area to accommodate industrial or utility-scale applications. Stranding is more complex than bunching, as it involves integrating subunits into one larger conductor while maintaining flexibility and strength. The stranded wires must be uniform and free of gaps to ensure reliable performance. Precise tension control during stranding is essential to avoid deformities in the wire. For multi-core cables, which include more than one conductor within a single cable, the layup and taping process comes into play. This process involves twisting several insulated conductors together to create a composite cable. This is essential in products like control cables, power cables, and communication cables. After the layup process, the cables go through taping, which is the application of non-conductive materials like mylar or PVC tape. Insulation is the core of a cable's functionality, acting as a barrier that protects the conductor and ensures safe transmission of electricity. The compounding process ensures that the insulation material meets the desired physical properties, including flame resistance and tensile strength. After compounding, the molten PVC or PE is extruded over the conductor, forming a protective sheath around the cable. In specialized plants like Nexans building wire plant, specific cables such as flat and orange circular cables are produced in high volumes. These cables are used extensively in construction projects and general electrical wiring in residential and commercial buildings. In the case of building flats, the cables are manufactured in flat geometries to make installation easier, especially in confined spaces such as wall cavities. Orange circular cables, often used for underground or industrial applications, are more robust and designed to handle higher currents. Nexans prides itself on manufacturing over 500,000 meters of flats per day. These products are wound onto recycled plastic spools, reflecting the company's commitment to sustainability and resource efficiency. Wooden reel assembly and finished goods processing. After the cables are manufactured and coated with insulation, they are wound onto reels, either plastic or wooden, depending on the application. The facility has an in-house wooden reel assembly line, which allows the company to tailor reel sizes to specific cable lengths and weights. This in-house process not only reduces lead times but also ensures quality control at every stage. Once the cables are wound onto reels, they are labeled with the necessary brand information and specifications. Branding not only ensures traceability but also aids in the quality assurance process. The cables are then stored or loaded for dispatch to clients. Cable fault detection and repair. Quality control is paramount in cable manufacturing. Fault detection methods such as high voltage testing, visual inspection, and dielectric testing are employed to detect any defects that may arise during manufacturing. The facility is equipped with fault detection equipment capable of identifying insulation breakdowns, conductor defects, or imperfections in the cable's outer sheath. In the event a fault is detected, repairs can be carried out immediately. This ensures that only fully functional, high-quality products leave the facility. Nexans Recycling Plant, Copper and PVC Recovery. Sustainability is a significant aspect of the company operations. In their recycling facility, the company focuses on reclaiming valuable materials such as copper and PVC. The recycling process begins by separating the copper conductor from the insulation and sheathing. Eldon and Redema recycling machines, like the Thunderhawk A, are used to handle cables with diameters up to 30 millimeters. These machines process up to 400 kilograms per hour, separating PVC from copper with high efficiency. Recovered copper has a purity level of 99.5%, which can be reintroduced into the production cycle or sold to external recyclers. Similarly, the reclaimed PVC is reprocessed into new compounds, reducing the amount of material sent to landfill. High-voltage cables consist of several crucial components: the conductor, insulation, water barrier, armoring for offshore cables, and an outer sheath made of black polyethylene, often reinforced with yarn for added strength in marine environments. The conductor, responsible for efficient power transmission, is created by twisting multiple thin wires of aluminum or copper into a full-sized conductor using specialized stranding machines. Depending on the specific needs of the project, conductors can have different cross-sectional designs. The heart of the cable system is the insulation, specifically made of cross-linked polyethylene, XLPE. This insulator is vital for maintaining the cable's integrity, ensuring that power can be transmitted without losses. The insulation is surrounded by semiconductive layers that provide smooth interfaces, while the closed extrusion process used in manufacturing ensures exceptional dielectric strength. During the production process, a free-hanging cooling technique is applied in high towers, resulting in unmatched performance. To protect the cable from water and provide additional electric screening, a lead sheath is applied, followed by a polyethylene (PE) sheath for mechanical protection against corrosion and physical damage. For 3-core AC submarine cables, individual power cable cores, and optional communication cables are assembled vertically into one large unit for easier installation. Offshore cables are particularly challenging due to harsh marine environments. To protect these cables, layers of steel armor provide additional tensile strength and effective corrosion resistance. The final layer, made from yarn, enhances the visibility of submarine cables when laid on the seafloor, ensuring easier tracking and maintenance. Before deployment, each cable is rigorously tested in NKT's factories to ensure it meets strict quality standards. Once approved, the cables are transported to the installation site. NKT Victoria can load up to 9,000 tons of cable, divided between 2 turntables, making the logistics seamless. The vessel itself runs on green electricity when docked, further emphasizing NKT's commitment to environmental sustainability. The installation process is carefully monitored by remotely operated vehicles, ROVs, and other tracking systems to ensure precise handling. The cable is then connected to the land-based infrastructure, completing the power transmission route. After the cable is installed, it undergoes final testing to verify its functionality before being handed over to the customer for operation. Web slings are strong, flexible, and used for lifting heavy loads. Their production involves several key steps. Warping. This is the process of aligning threads, yarns, in the lengthwise direction to create the base of the sling. Weaving. The warp yarns are then woven together with weft, crosswise, yarns to create a strong, durable fabric. This weaving process provides the web sling with its strength and flexibility. Dyeing. The woven fabric is dyed to meet color coding standards that signify the strength and capacity of the sling. Information such as load limits and manufacturer details are printed on the fabric. The fabric is then cut into specific lengths depending on the intended use of the sling. Manual stitching. In some cases, reinforcement is added manually to high-stress areas, ensuring additional durability and strength. Automatic stitching. Most stitching is done automatically to ensure precision. The edges are sewn, and eyes, lifting loops, are created at the ends. Round sling assembly. For round slings, endless loops of yarn are enclosed within a fabric sleeve for added strength. Fusion. The final step may involve fusing certain parts of the sling, such as attaching labels or joining components, ensuring everything is securely fastened. Van der Lee is a distinguished company specializing in the production and distribution of high-quality rope products, catering primarily to businesses with specific needs in the offshore, maritime, and industrial sectors. Located in Oudwater, the company's approach is heavily customer-oriented, offering both standard and customized rope solutions. With a long history dating back to its inception, the company has built substantial expertise in rope making. Originally, rope was primarily crafted from conventional natural fibers like flax, hemp, manila, and sisal. Over time, especially since 1965, the company has embraced synthetic fibers and modern materials such as nylon, polypropylene, polyester, and high modulus polyethylene (HMPE). These new materials have significantly increased the breaking strength and durability of ropes, allowing the company to expand its product range and address more demanding applications. Despite the adoption of advanced synthetic materials, there remains a strong demand for ropes made from natural fibers due to their aesthetic and traditional qualities. The company has maintained its capacity to produce both types of ropes, using the ancient art of rope making while continuously innovating to meet modern requirements. The manufacturing process at the factory incorporates both traditional and synthetic materials, enabling the production of ropes for diverse applications. Some of the key materials used in rope production include natural fibers, manila, flax, sisal, and hemp, which remain popular for certain industries due to their biodegradable nature and traditional appearance. Synthetic fibers, nylon, polyester, and polypropylene are preferred for many applications due to their high breaking strength, durability, and resistance to environmental factors. High-performance fibers, high modulus polyethylene, HMPE, and other superfibers, such as Dyneema SK75, offer exceptional strength-to-weight ratios, making them ideal for critical applications like mooring and towing in the offshore and maritime industries. The versatility of these materials allows Van der Lee to create ropes that meet stringent technical specifications, such as high load-bearing capacity, UV resistance, flexibility, and durability under varying environmental conditions. One of the company's strengths lies in its ability to provide bespoke rope solutions tailored to meet individual customer requirements. Their compact team of advisors collaborates closely with clients to match their unique needs with the right technical capabilities. This flexibility is particularly valuable in industries like offshore operations, maritime shipping, defense, and industrial sectors where specific rope characteristics, such as length, strength, and material composition, are critical for safety and performance. The factory manufactures a wide range of products, including abseiling ropes, used by elite units like the British Army for climbing and rescue operations. Mooring and towing ropes. Delivered through the Hendrik Veeder Group, these products serve the offshore, maritime, and defense industries. Winch lines and shock-absorbing ropes, essential for lifting and towing applications. Anchor systems. Designed to meet the demands of heavy-duty marine and offshore projects. Their ropes are also used in other sectors such as sport hull installations, agriculture, fishing, and even decorative applications in yacht building. At here, quality is an uncompromised priority. The company ensures that all products meet the highest safety and performance standards through extensive quality control and testing processes. The factory is currently working toward certification under the latest ISO 9001 standard, demonstrating its commitment to maintaining and improving quality across its entire production line. Ropes play a critical role in the heavy lifting industry, especially in regions like Rotterdam, Aberdeen, and Stavanger, which are hubs of energy and offshore operations. Billions of euros worth of structures, vessels, and equipment require reliable lifting, towing, and mooring solutions, where the importance of both steel wire and fiber ropes becomes evident. Companies like the Hendrik Veeder Group specialize in providing such ropes for these demanding tasks, combining centuries of experience with modern technological advancements. Fiber ropes, made from materials like polyester or denim, also have a place in the industry due to their lightweight yet strong properties. These ropes are often used when weight savings are crucial, such as in deepwater mooring or towing operations. Despite being lighter, these materials offer significant strength, allowing them to complement or, in some cases, replace steel wire ropes in specific applications. Steel wire ropes, for instance, are essential in the offshore and maritime industries for their strength and durability. The Hendrik Veeder Group designs and manufactures steel wire rope slings, as well as grommet slings, which are tailored for the most strenuous jobs. These ropes are tested under extreme conditions, with proof load and breaking load tests exerting forces of up to 1,250 tons. Such tests ensure that these ropes can withstand the immense stresses they will encounter in heavy lifting operations. The company's capacity to produce a 280-meter-long cable-laid sling, the longest ever made for Sapem, demonstrates the scale and precision of their work. The anchor chain manufacturing industry plays a crucial role in maritime operations, producing robust chains capable of withstanding extreme conditions. The manufacturing process typically begins with selecting high-grade steel, with a tensile strength ranging from 400 to 1,000 megapascals, depending on the application. This steel is then heated to approximately 1,200 degrees Celsius, 2,192 degrees Fahrenheit, and formed into chain links using automated chain bending and welding machines. These machines are designed to handle chain sizes up to 165 millimeters in diameter, producing links that can bear loads of up to 500 tons. Once formed, the chain links undergo a process of heat treatment and quenching to enhance their strength and durability. Each link is tested to ensure it meets specific standards, such as those set by classification societies like American Bureau of Shipping or Det Norske Veritas. For instance, anchor chains for large commercial vessels may require testing at up to 60% of the chain's breaking load, often exceeding 300 tons of tensile force. The finished chains are coated with corrosion-resistant materials, such as hot-dip galvanizing, which applies a protective zinc layer approximately 85 microns thick, extending the chain's service life in harsh marine environments. The manufacturing of cold-rolled continuous spiral blades involves a specialized rolling process. A flat metal strip, typically carbon steel or stainless steel, is fed into a rolling machine. Through precise pressure and control, the strip is formed into a continuous spiral shape without heating. This cold rolling process ensures high strength, dimensional accuracy, and smooth surface finish while maintaining the metal's structural integrity. The spiral blade is typically used in augers, screw conveyors, and mixing equipment. Its continuous design offers efficient material handling and mixing capabilities. After forming, the blade undergoes further processes such as trimming, polishing, and heat treatments if necessary, to meet specific application requirements. The chain link fence manufacturing industry is a significant sector that produces durable and versatile fencing solutions used worldwide in residential, commercial, and industrial applications. The manufacturing process typically involves several key steps, including wire drawing, galvanization, weaving, and coating. The process begins with drawing steel wire, usually made from low-carbon steel with a diameter ranging from 2.5 mm to 4 mm, depending on the strength requirements. After wire drawing, the wire is galvanized using a hot dip process, applying a zinc coating of 35 to 70 grams per square meter to prevent rusting. Galvanized wire is then woven into a diamond-shaped mesh by automatic weaving machines. These machines can produce mesh with apertures ranging from 25 mm to 100 mm, depending on customer specifications. A standard chain link fence roll typically measures 1.2 to 3 meters in height and 15 to 30 meters in length. In terms of production capacity, an average plant can produce up to 2,000 square meters of chain link fence per day. The fences can also be PVC coated for enhanced corrosion resistance and aesthetic appeal, with coating thicknesses ranging from 0.2 mm to 0.4 mm. The global chain link fence market is estimated to grow at a steady rate due to rising infrastructure developments, with countries like China, India, and the US being major consumers. The market size was valued at approximately $3.2 billion in 2021 and is expected to reach $4.5 billion by 2028. In India, the steel industry plays a critical role in economic development, contributing significantly to infrastructure and manufacturing sectors. Integrated steel plants form the backbone of the steel industry, producing a wide range of steel products using sophisticated technology. One such example is Komatsu Group's integrated steel plant in Chennai, with a state-of-the-art bar rolling mill. This plant highlights modern rolling mill technology and showcases India's capabilities in steel manufacturing. Komatsu Steel's bar rolling mill in Chennai is a testament to the company's focus on adopting advanced rolling technologies to deliver high-quality steel products. The facility produces a wide range of steel bars, including round bars and rebars, which are essential components for construction and manufacturing industries. The production process, from starting stock to finished product, is carried out with precision, efficiency, and environmental sustainability in mind. Starting stock. Billets. The starting stock for the rolling mill comes in the form of billets, a semi-finished product used for further processing into various steel shapes. Billets of these dimensions are fed into the rolling mill, where they are reheated and subjected to multiple stages of rolling to reduce their cross-sectional area and transform them into the final product shapes. Finished products, round bars and rebars. Komatsu Steel's rolling mill is designed to produce two main types of steel products, round bars with diameters ranging from 12 mm to 40 mm. Rebars with diameters from 8 mm to 40 mm. Both round bars and rebars are crucial in various industries. Round bars are used in the manufacturing of shafts, machine parts, and fasteners, while rebars, reinforcing bars, are essential in the construction industry for reinforcing concrete structures. One of the standout features of Komatsu Steel's bar rolling mill is its use of slit technology. Slit rolling is a highly efficient process that allows multiple strands of steel to be rolled simultaneously, resulting in significant cost and time savings. This multi-strand rolling method ensures a higher output rate without compromising product quality. Slit technology also enables better utilization of furnace capacity and rolling equipment, leading to increased productivity. The reheating furnace at Komatsu Steel's bar rolling mill has a capacity of 60 tons per hour, (th), ensuring a continuous supply of billets to the rolling mill. The furnace plays a crucial role in bringing the billets to the required temperature for rolling, typically between 1,100 degrees Celsius to 1,250 degrees Celsius. With this furnace capacity, the plant can produce up to 400,000 tons per year of finished steel products. This annual capacity is significant for meeting the growing demand for construction materials and industrial components in India and overseas markets. The rolling mill at Komatsu Steel operates at impressive speeds to enhance productivity. The facility uses two rolling methods depending on the type of steel product being produced. Single-strand rolling. A rolling speed of 16 meters per second is maintained for single strands of steel. Slit rolling. Slit rolling is slightly slower, with a speed of 14 meters per second, which is still highly efficient for multi-strand production. The mill is capable of producing steel products in various grades, catering to different industrial needs. These include low, medium, and high carbon steel, used in various applications such as construction, automotive, and machinery manufacturing. Cold heading steel, specifically designed for cold heading processes, where steel is formed into fasteners such as bolts and screws. Ball bearing steel, high carbon chromium steel used for manufacturing ball bearings. Spring steel, a high strength steel used in the production of springs and other components that require resilience and flexibility. Advanced rolling technology for straight bars. Komatsu Steel's rolling mill is equipped to roll straight bars with cross-sectional dimensions ranging from 8 mm to 100 mm. The ability to roll round cross-sections, as well as standard and special profiles, allows the plant to cater to diverse customer requirements across different sectors. Whether for infrastructure, automotive, or industrial applications, the rolling mill can produce bars with the mechanical properties and surface quality required for each specific use case. The rolling mill's technological setup includes the option to connect multiple production lines, including wire rod outlets, spoolers, and Garrett coiler lines. These additional lines provide flexibility for producing not just bars but also wire rods and coiled products, further enhancing the plant's versatility. Finishing speed and product quality. One of the critical factors in any rolling mill is the finishing speed, which directly affects product quality and efficiency. At Komatsu Steel, the finishing speed of the rolling process ensures the steel bars have the right dimensional accuracy, mechanical properties, and surface finish. The plant's advanced cooling systems and finishing equipment guarantee that the final products meet stringent quality standards. The plant's ability to produce bars at high speeds without sacrificing quality is crucial for meeting the demands of modern construction and manufacturing industries. Whether it's the precision required for machine parts or the strength needed for reinforcing concrete, Komatsu Steel's bar rolling mill delivers high-performance products. Sustainable steel production. Sustainability is a key consideration in modern steel manufacturing, and Komatsu Steel's integrated steel plant incorporates energy-efficient technologies to minimize its environmental footprint. The use of slit technology, in particular, reduces energy consumption by maximizing furnace and rolling efficiency. Additionally, the plant's reheating furnace is designed to operate with low fuel consumption, further enhancing the sustainability of the steel production process. By producing high-quality steel products with minimal resource wastage, Komatsu Steel contributes to the broader goal of sustainable industrial development in India.